Okay, video recording of lesson 10 titled Data Processing, Declarative Programming, and LINQ. That's right, these four letters here, LINQ, are pronounced LINQ. And as with most lessons, I'm combining material that doesn't necessarily need to be talked about in combination, but we're combining them because we want to accomplish some goal, and these are kind of the requirements for accomplishing that. So the goal we want to accomplish is processing and analyzing a large real-world data set using C#. Okay, so in the first lesson of this course, I showed this diagram with all these different developer roles, and we were going to talk about the different tools that people in these different roles might use on a software development team. And of course, we've been talking about the developer role or the programmer role from the start of the course till now. And now we're kind of bleeding into this business/data analyst role. And I have plans for why I sectioned these roles like this, but for now, with our tool graph, I'm just going to throw these two together because in our course, a business analyst or data analyst is going to use C# to do analysis. Okay, so data analysts could use Excel, they could use Python, but we're using C#, so I'm just going to pair these two together, and we're still using all the same tools, except we kind of have a different goal in mind. Okay, so the general goal of data processing or data analysis, or whatever you'd like to call it, is kind of embodied by this triangle. So this triangle says that we might have some data, some raw data, and that's kind of the lowest level of information here. And we want to take this data and we want to try to build usable information out of this data. And then from here, we want to be able to analyze this information to be able to produce some knowledge from this data. And then lastly, we want to be able to extrapolate that knowledge into some form of wisdom. So that's generically what we're trying to accomplish or to describe with this triangle. But let's look at it a little more specifically with an example here. So say we have this data. This is just raw data here. We have some names here, an age, a check-in date, and this column called fatal that has a nowhere yes value. Now, this data doesn't really mean anything by itself until we kind of give it some context and understand it a bit. And when we do that, it becomes information. So if we say that this data represents COVID hospitalizations for University of Iowa hospitals, then it starts to make sense. Okay, so Jane came in with COVID on this date, John came in with COVID on this date. It was fatal, his case of COVID. Jamal came in with COVID on this date, Julie came in with COVID on this date, and so on. So this data means more when we add this context, and from here we have information. Now, when we move up the hierarchy to the next level, we want to try to produce some knowledge. So from this information, we can determine that because University of Iowa has a max capacity of, for example, 1,500 beds, we can look at this information and see that Iowa will reach its max capacity in January 2020 here. So the hospital particularly. So we've kind of pulled out this knowledge that in terms of the capacity of our hospital, we might be in trouble, we might be running out of capacity based on the information we're collecting. And then from here you can extrapolate some piece of wisdom such that the University of Iowa hospital should make effort to increase its hospital capacity in the January months to ensure that it can meet demand. Could accomplish this by placing competitive bids for traveling nurses and using Kinnick Stadium for extra space to house patients, something like this. So we have taken our data and ultimately we used it to make a decision about how we should act. So that's the general goal of this. And to be clear, I don't know if any of these things are real. This is just an example. Okay. The next idea I want to introduce here before we move on to the exact C# details is this difference between imperative and declarative programming. So these are two programming paradigms or programming styles. And to talk about these styles, we'll say imperative programming, when we're doing imperative style programming, we are telling the program how to produce the desired result. We're telling it how to produce the desired result. And as such, we write code that exactly details the process a program should follow to accomplish what we want. Okay. In declarative programming, all we do is tell the computer or the program what we want, and we don't concern ourselves with how it gets accomplished. Okay. And so, generally this means that imperative programming is longer. You have to write more code because you're trying to detail every step. With declarative programming, it tends to be shorter, more concise, sometimes a little bit harder to read, depending on the situation. But it's shorter because all we have to do is tell the program what we want. And so kind of to understand this a little better, the example I'll use is declarative programming is Amazon. Amazon is declarative, okay? So Amazon, you tell them, hey, I want this package and I want it by this date. You tell them those two things, they'll figure out all the logistics that need to happen to get that package to you on time. So they'll figure out, okay, well, based on where it's stored, what's the best mode of transportation? Based on local weather, do we need to transport it in different ways? They'll figure out all these things for you and all the logistics, and it just ends up on your doorstep for you. On the contrary, Facebook Marketplace or maybe Craigslist is imperative. So you have to work out, well, who has the thing you want? Okay, you got to figure out, you got to find the person who has the thing you want. You have to pick a time, pick a place. You got to meet. If it's a big thing, you need to find a friend with a truck. You got to work out all these little details in order to get the thing you want. So that's kind of the different, I guess, vibes between declarative programming and imperative programming. And we'll see this difference take place in C# and in this lesson. One more slide here about it, though, is programming languages kind of fall on a spectrum between being imperative and declarative. And on the declarative end, you have languages such as SQL. If you've written SQL, you don't tell the database how to get the information you want. You just tell the database what you want, and it figures out how to get that information to you quickly and correctly. Same thing with HTML. If you've written HTML, you don't tell the web browser how to put what pixels where on the screen to make it look a certain way, right? You don't tell it how. You just say, I want this thing. Okay, you want this thing, and then you kind of magically shows up there on your web browser. Kind of on the weirder end of declarative programming, we have languages such as Lisp and Haskell, and they have their purposes. On the imperative end, we have things such as C and binary, right? So, these languages are working directly with the computer, telling it how to do every little step. They're low-level programming languages, and as such, they end up being very imperative. You have to be very explicit about what you want the computer to do, because the computer can't think for itself. So these are very imperative, and then we kind of have this middle ground. Again, imperative and declarative are just kind of concepts or vibes of programming. And so you can write declarative code in Java or Python or C# based on how you write your classes or your methods or how you design your objects. You can make things feel declarative in these languages, but they also, at the same time, they also tend to be more imperative in terms of most of the code you have to write in them. And another, possibly a better example of that is between JavaScript and React.js. So JavaScript is a base language. It sits somewhere in the middle between being imperative and declarative. And React JavaScript, React.js, all it is just JavaScript, except it's built this entire framework and set of libraries around JavaScript that makes it easy to do certain things. So because of all the support of the libraries and the framework, it makes this language feel more declarative when you're using it. So again, it just illustrates that you can put effort in to make your code feel more declarative if that's important for what you're doing. Okay. So with that, we'll get into some specific examples of doing this with C#. The first C# feature I want to introduce here is the var keyword. And I've been avoiding this keyword, this var keyword, from the start of the course because it kind of obfuscates the idea I want to enforce, that all your data needs to be associated with a type in C#. And so that's still true even with the var keyword. But what the var keyword says is when you're declaring a local variable, as we know, we have to give it a type, the local variable a type. The var keyword says, well, just make me the type of whatever is on the right of the equal sign. So on this data on the right of this equal sign is a bank account, is of type bank account. And so we can put var there, and C# will figure out, okay, well, bank account is really this. It's of type bank account. All right. So it's like this syntactic shortcut, and it can only be used for local variables. So you can't use this when denoting the types of your properties or your methods or your method parameters. You can't use it there, but you can use it for local variables. And it's going to be kind of helpful for us in this lesson because, as we'll soon see, the thing or the type of the thing on the right of the equal sign is going to change often. It's going to change often. Like we'll type some characters and it'll be one type, and then we'll type some more characters, and then the type will change on what is to the right of the equal sign. And so if we didn't have the var keyword, we have to constantly keep updating the type of our variable. So it comes in great handy in this particular lesson. Okay, so now with that, let's talk about LINQ. So LINQ stands for Language Integrated Query, and LINQ is a declarative programming feature that is built into C# that allows us to write queries on collections. You could also think about collections as just a list of objects. Okay, it's kind of a more generic word for list of objects. Okay. And a query could be defined as one of the following, and more, really. But we can say a query is, for example, a request for a subset of data from your list. Okay, so if you have a grocery list, you could write a query for your grocery list and say, of this grocery list, find me all the fruits on my grocery list. Okay, so there's your query. It's like a question you're asking your grocery list. Okay, and another thing you could kind of express is in your query is kind of a question you want an answer to or a calculation. So, example: find the amount of calories for the food on my, or the average amount of calories for the food on my grocery list. Okay, so it's like a question you're asking your grocery list. Can you calculate the average caloric content of all the items here? Okay, so it's another example of a query. And then this one's a little bit stranger. So A query can be a request to derive a new set of data or a new list of objects from our existing list of objects. And I didn't put an example up here because this is kind of a, it requires a little more visualization, but we'll talk about this, okay? Okay, so with that, we are going to be introducing, for the sake of these slides, this object, this class. So the class is an academic institution, and it has some properties, so a name, a type, or an institution type, a state, the amount of students at that institution, and the graduation rate at that institution, right? So it's just a normal class as we've seen, and as we saw with lesson 9, we can load this data from a CSV file using CSV helper, and what we get back is a list of academic institution objects. Okay, so institutions is our list of objects, and we're going to use LINQ to write queries about this list of objects. Okay, so let's say our query is we want to find all the academic institutions in Wisconsin. Okay, so we have our institutions defined up here. Find all the academic institutions in Wisconsin. Okay, so the imperative way to do this, right? We tell the programming language, we tell C# exactly how you do this thing. How do you find all the academic institutions in Wisconsin? Well, how do you do it? You create this new list here, this academic institution, a new academic institution list called Wisconsin institutions. You loop through your existing institutions, and you check, you have a little if statement. If the state equals Wisconsin, then you add it to your other list, and then you have your other list, and you use the other list from now on. So that's the imperative style programming. And in declarative programming, we can say this in less words. We can say, we have a new list here, Wisconsin institutions, and how do we calculate Wisconsin institutions? How do we tell C# what we want? Well, we use this thing here, right? We just use this thing here. We say where the state is Wisconsin, and it kind of looks like our if statement, really. So we'll talk about exactly how to think about this syntax, but you see it's much shorter. Okay, so Wisconsin institutions is just all of our institutions where the case is the state of the institution is in Wisconsin. Okay, so that's kind of the idea here. You see this one's much shorter, much more concise than this one. And then another thing I'll point out, you'll see that this type here is an IEnumerable of academic institution, an IEnumerable of academic institution. And so all of your, a lot of your LINQ queries will return these IEnumerables. For now, you can think about IEnumerables as just a list that you can't change, a list that you can't add items to, a list that you can't remove items from, a list that can't change. We can think about an IEnumerable like that. If you ever want to get a list when you have an IEnumerable, you can call toList here. Okay, so breaking down this LINQ syntax, right? This where clause here, or this where method, this is LINQ syntax coming in. So we have our regular list of institutions, and again we're doing institutions where the school, and then you have this arrow here, this arrow syntax here, and this arrow syntax is referred to as a lambda, but I think more accurately, or a more descriptive name of what it is an anonymous function, okay? And an anonymous function is a function without a name, okay? A function without a name. So how we have to think about this is what we're providing our where clause is a function that takes in an academic institution, right? So this is just a variable name. So I'm calling it school because that's kind of helpful for thinking about this. It's just a variable name or a parameter to your function. So a function that takes in an academic institution as a parameter, and given that academic institution, it tells you whether that institution meets the criteria you want. So you'll see this returns a Boolean. This returns a true or false value, right? It's kind of like our if statement. Our if statement needs to operate off of a true or false value. That's what's going on here. So a function that takes in an academic institution and returns the result of whether that academic institution meets our criteria or not. Okay, so that's kind of how to read this. And more generally, anonymous functions can show up everywhere, but in this context, this anonymous function is called a predicate. So you don't have to remember that, but there's a specific name for writing anonymous functions that take in an object and then return a true or false or a Boolean value, and that's a predicate. Okay. Okay, so another example here. Let's say we have a query where, for the query, we want to calculate how many students are in Wisconsin, and so again, we just showed how to get all the schools that are actually in Wisconsin. So we use that where clause, and we can, after we get all the students that are in Wisconsin using this where clause, we can then use a sum clause to describe the criteria for summing what we want to sum. So again, it's another anonymous function where, given a school, we return the value on that school that we actually want to sum. Okay, so this type of anonymous function is generally referred to as a selector. Okay, because think about it like this, right? Given a school, select the actual thing about the school that you want in this scenario. So in the scenario of summing for student counts, the thing we want to select is the student count. Okay, so that's a selector. Okay, a few more examples here. So here we have a similar thing to the previous example. So say we want to determine all the institutions that are in the Midwest. Well, we can create a list of the states in the Midwest. So here we're using abbreviations. We were using full names, but we're using abbreviations here. And we can use the contains function here to determine if a school state is a state that exists in our array of Midwest states. So you'll see here this contains returns a true or false value, so we can use it here in our anonymous function or in our predicate function. Okay, so anything that returns a true or false value is good here. Okay, and here's another example. So again, similar to the previous one where we summed the student counts, we can first find all the schools that are in the Midwest to sum the total number of Midwest students, right? We can find the schools that are in the Midwest, and then from there we can perform a selection. So here I'm performing the selection in a separate step from the summing. So we perform a selection to get the value we want from our objects. And the value we want is student count. And then after that, we tack on the sum to say, okay, now that you've found all these values or selected all these values, now I want you to sum them all up. So if we kind of look at this in an intermediate step, so in an intermediate step, if we just did the select without the sum at the end, we would get back a list of integers because it has selected out that property from our object. And so this just corresponds to a list of integers. Okay. A couple other kind of methods or clauses, you might hear them called as, that you can put on your LINQ queries here is ordering. So if you wanted to order the Midwest schools by name, you just do a .order by, and again, this is a selector. This is a selector. You're saying, given a school, what property do you want me to use to determine the order of the school? Okay, and you'll see that this returns an I-ordered enumerable. So hopefully you're seeing why we might like the var keyword, because the types are going to get weirder and weirder over here. So using the var keyword kind of handles this all for us. And of course, you can order by in ascending order. You can also order by in descending order. So this gets us all the Midwest schools where we are selecting out the student count, but we want to order it by descending order so that the biggest schools are the first items in our list. Okay, so another example right there, order by clause or order by method. Okay. Okay, grouping in LINQ. So grouping allows us to split or partition our collection into groups of collections, or you could say split our lists into groups of lists, or split our lists into lists of lists. So a couple different ways you can think about it. And hopefully you're seeing here why we might like the var keyword. The types on the left here are just getting ridiculous. I mean, there's so many angle brackets here and so much syntax, and the var keyword will allow us to just omit all of that right there. So let's look at the group by here. So we're saying our variable groups is equal to institutions dot group by, and then we're selecting the criteria we want to partition our list by. So we're saying we want to group our list by state. So what we get back from that is a list of key value pairs where our key is what we partition by. So our key is a state, so Illinois, Iowa, Wisconsin, whatever it is. And our value is a list of objects that were associated with that key. So, in the case of our data set, Iowa would be the key, and the value would be a list of all the academic institutions that are in Iowa. Okay, and then you have a list of those key value pairs. Okay, so you can think about it like a list of lists. And so that's the idea of grouping, and we can use grouping to create derivative sets. So let's say we wanted a list of states. Let's say we have information regarding a list of institutions, but say we wanted to think more on the state level. We want to think about the states. So we can use group by to do that as well. So again, we can take our groups and we can create that partition in it, and then from our partition we can do a select, and this is where the selectors get really interesting. We can select, given a group, we want to produce a new state out of that group. Okay, and now we're putting instructions in here for how to aggregate those institutions to the state level. So we're building a new state, and the name of that state will just be the key of the group. Iowa, Illinois, Wisconsin, whatever it is. And the student count, we're saying to produce the student count for all the students in a given state, we have to sum all the values that are part of that key, and in particular, we're summing the student count values. Okay, so we're saying a lot here in very little syntax. So we'll show another example of this in our exercise. It's kind of strange. Okay, so one last thing that I want to mention here is there's actually two different ways to write LINQ in C#, and what we will focus on in this course and in these lessons and exercises is method syntax. So that what we just showed was method syntax. You want schools in Ohio, you write where school, arrow, school.state equals Ohio. That's how you write it. But if you're searching online for information about LINQ, you might run into this query syntax where people are writing LINQ like this: from school and institutions, where school.state equals Ohio, select school. So this is kind of like SQL if you've written SQL. But we're not going to use this syntax. You could use it on your assignments, but yeah, we won't cover it. So just understand that if you're looking for something and you want it, what you're looking for to be familiar to what we show in this course, you want to look for the method syntax. Okay. So with that, we'll move on to the lesson 10 exercise. We'll use all of this to actually analyze a real-world data set. Okay, so the lesson 10 exercise will build off the last exercise we did in lesson 9. And as we discussed there, we had a data set for electric generation data for power plants across the United States. And we got this data from here, from the U.S. Energy Information Administration. And we performed some small manipulations to the data, and the manipulated result is linked on our icon page. So I'm going to download that. And let me create some space here. Okay, so downloading this, and I want to place it, come on, here we go, into storage. Okay. All right, so got the file there, and this exercise has some starting code that is here. So I'll go here, I'll go to Visual Studio, and I will clone a repository. I will paste it, and yeah, we'll clone it there. Okay, I'm gonna right click on this, and I'm gonna do copy as path, get the path of this file, and okay, so this is similar to our lesson 9 exercise where we ended with on lesson 9 exercise 2, but I made some modifications just so things can go smoother for lesson 10, and we can focus on you know, some important things such as LINQ and not kind of getting everything set up exactly right. So I've made some modifications, but hopefully you can see that the modifications aren't too different from where we left off in homework or in lesson 9. So here we see we have our main program, and it takes in the file path from the program argument. So I'm going to go ahead and put that in. And okay, so I put in the path to that file. And if we just run it, it should print out something similar to what our program printed out at the end of lesson 9. Hopefully. Okay, so while that, oh, there we go. Okay, yeah, so it prints out the data. And I'm going to go ahead and comment this out. Okay. And before we had the CSV helper, we were using that directly in the main program. what I've done is I've moved that logic into this class called Power Plant Generation Unit Data Service. Okay. Yeah. So that reminds me, I should pull up our data set and actually provide some explanation about it. Okay. So I've just moved all the CSV helper into its own class so that it's not in the main program and we don't have to worry about it in the main program. And if we look at this data set, I'm going to autofit column width so that we can actually see the names of our columns. So okay. Okay. It's a little messed up here. All right, that's better. Okay, so it's power plants across the United States. Power plants that are generating electricity, and you'll notice here the same power plant, right? So this Berry power plant operated by Alabama Power Company with the ID3. There's multiple rows in here. Okay, so if you've taken a relational database course, you could think of this data as not being normalized, right? So we're duplicating data across multiple rows. But let's get to the reason why there's multiple rows. So the reason there's multiple rows is because a power plant has maybe several different forms of generating electricity. So if we look at this Berry power plant and we go over to the right here to this column, we'll see these fuel type codes. And so this is saying, well, this power plant is burning natural gas, and this power plant is burning bitumen, or it's burning coal, and I know what these abbreviations are, and have some code in our solution for helping us decode these abbreviations. But the power plant's burning multiple different types of fuel, and it's using multiple different pieces of equipment to do that. So and that's what this is. So for every piece of equipment or every generation source at a power plant, we have a row in our data. So when I called our objects power plants in lesson 9, I actually wasn't correct. Really, these are power plant generation units. These are one unit of one generator at a given power plant, and you'll see that's in this class here, which is pretty much the same as the one we generated in lesson 9. In lesson 9, we generated this using the CSV data to C# class. But I've made some small changes, so some dependent properties that translate these codes we're seeing here. So these codes, they translate them into readable names. So that's what this class is, the abbreviations to names helper. And if we look at that, all it is just static data here of bringing us from code to a good description of it. So these go to coal. Natural gas is a fuel. Nuclear is a fuel. Tire-derived fuel, that's interesting. Biomass solids. There's a lot of different fuels that the plant could be burning using different equipment, and then these codes here are for the equipment. So here, wind turbine onshore, wind turbine offshore, combined cycle steam part, photovoltaic, solar, right? So a lot of different equipment, and what this stuff is not all that important. I just understand that there's different units for generation here. Okay, so that's that class. What else have I done to it? I've also added some attributes, and these are described in the comments on this class. and so on. Okay, so there's that one, and then we have these other classes. So we have the power plant class. So this is actually a power plant. So this we're going to create a derived set of power plants, and we're also going to create a derived set of states, kind of like we did in the slides. Okay. Okay. So that's that. That's that, and of course there's a lot more data in here. So we have some temporal data, so we can see different things about the generation across the months. Okay, so but we're going to skip over all of that. Skip over all of that. Skip over all of that, and go to the end here. And so this is actually what we're going to be. These are the numerical values we're going to use. So the important one here is net generation in megawatt hours. So this is how much electricity this generation unit generated, and we measure that in megawatt hours. Your utility bill it probably measures it in kilowatt hours, but it's just a bigger unit of electricity. And the other value here is that we're going to want to look at is the fuel consumption, which is essentially the energy that's in the fuel that you might burn. So the energy that's stored within the hydrocarbons in the coal or the natural gas, or the energy that's stored in the movement of the wind, and we measure that in MMBTUs. So that's these two pieces of data here, okay. All right, so what's next? So that's our data set, and we perform these calculations here. Okay. So first thing we want to do is, well, actually, I'll say the first thing I want to do. So if we scroll down, we have these weird things here. These state fuel level increments. Okay, so this is I don't know if EIA adds this data in to correct some things in the data, but this is not really a power plant. So I'm gonna copy this string here, and the first thing I'm gonna do is I'm going to do a where clause where the plant name does not equal this. Okay, so and then we got a to list here. So I'm just trimming the data a little bit. So if we do something like this, and hit a breakpoint here, let's see how it goes. We might have to close this file, actually. Okay. Okay, so here's the full count. So this is with that weird data at the bottom, and now I'm trimming it. So I only want the ones that's the other power plants, and you see it's about 1,000, a little more than 1,000 records shorter. So here we had our where clause that trimmed up that data for us. Okay, so and if we hover over this, right? So as we saw in lesson 9, we have our list of objects where each object is a generation unit at a given power plant. Okay, so now with that, let's start writing LINQ to do what the exercise asks for. So how much wind electricity was produced in the US? Okay, so I'm going to use the var keyword, US electric generated. And we can go generation units dot where, and then we want to do dot where, and the property I want is reported fuel type name, and I want to do contains. Well, let's do this. To upper contains wind. Okay, so the reported fuel type name, if I hold control and click on it, it brings me here. Okay, so we see this is a dependent property, and we calculate this dependent property by taking the data we have, so our reported fuel type code, this is the abbreviation on the Excel, and we call this toFuelName method, and then it looks it up in our dictionary, and we find it. So if this name contains the word wind, then we're good. Then we know that that's what we're looking for. So we want where that it contains wind, and then we should just be able to sum. Well, what are we summing? We are summing the net generation in megawatt hours. Okay, and a common thing we see with LINQ is you kind of put these on separate lines here, and that's okay because the semicolon is what's going to terminate the statement. Okay, so and if we hover over this, we'll see it knows it's a long, so the data type is a long, even though we put var here. We could put long here, but we're going to keep it like that. So we do our console.writeLine. And right to the console. US electric generated. Okay. Megawatt. And this is for the whole year. This data set is over the course of a year. Okay, so that should give us US. Okay, and yeah, if we want to format that so that we can read it like a number, we can do a toString and then n and then 0 as a formatting parameter. Okay. And here we go. So 271 million megawatt hours over the course of the year. And if we want to do Iowa, so here's the nice thing. So I can just copy this, and we can do Iowa, and you can stack your where clauses. So I can say, okay, well, before we look for wind, let's make sure the generation unit, so the state of the plant is equal to Iowa. Okay, so we can adjust this here. And there we go. Okay, good. So we see Iowa was 28 million megawatt hours. So that's pretty good. That looks about 10% of the country's wind energy is from Iowa. Okay, so there's our two link statements there. And then we'll move on to 2. So what are all the power plant providers that operate in Iowa? Who are all the power plant providers that operate in Iowa? So for that, power providers. So for that, we can take our generation units and we can do this same where clause. So where the generation unit is in Iowa, and we can select out of this the operator name, okay? And then we can use our for each loop. Okay, so this selects them. It's not ordered yet, but let's just verify this works. Okay, good. So we see it, but because we have multiple generation units and multiple plants that are operated by the same company, we see that this information is duplicated on our output. And so if we want to not duplicate that, we can do a distinct. Okay, we do the distinct. And that trims it up. Okay, so and then we can do the order by. Okay, yep, and I have to tell it what I want to order by. And the thing is, because at this point, this is just a list of strings, so I just want to order by the whole string. Okay, and then there you go. There's all the power plant providers, or yeah, the plant operators in Iowa in alphabetical order. You see University of Iowa's on here. We operate our own power plant. Mid-American Energy's on here. They provide power for most of Iowa City, and so on. A lot of power companies here. Okay, so now it's very common with these link statements to be writing X, right? X is your parameter name. But you know, if you want to think about it more more descriptively, you know, this is a unit in this case, and here this is a unit, and from that unit we're taking out the operator name. So at this point, this is a operator name, right? But you could just use X for all of that. Okay. So third one, what energy plant produced the most electricity? And so now this is interesting because we don't have energy plants, right? I mean, we kind of do, but we have generation units. And so if we want to just know, well, what did the whole plant generate and not each individual unit, then we have to do this aggregation, okay, or generate this derivative set. And so that's what this power plant class here is for, okay, is for storing the result of this aggregation. So to do that, we want to do max producing power plant, something like that. And to get that, we have our generation units. From our generation units, we want to group by the plant ID And then from our groups, we want to select a new power plant, and we can give it so because we group by plant ID, we know the key is going to be plant ID. Hold on. One too many curly braces here. No. There we go. Okay, and instead of X, I'm going to use group here. It's a little more descriptive. Okay, so we're selecting out the power plant, and the name of the power plant, we're going to have to look into our group and select a record out of that group. So we'll just select the first record. Okay, and from there, we want to also get the state. So state equals group dot first dot state. And okay, and now we want the actual generation. So now from this, we can do group dot sum and then tell it what we want to sum, and that is the net generation in megawatt hours. And then we can do the same thing for this last property. So electric fuel consumption. Okay. Yep. Okay. So this selects it out, and this is a lot going on here, so let's use this debugger to just inspect what this result looks like. Maybe. Computer's having a hard time managing the video recording software and Visual Studio at the same time. Okay. All right, you might have to run that on your own. So let's do an order by descending, and let's tell it what we want to order by. We want to order by the electric generation. Okay, so this should get us our result. Okay, and hopefully we can manage running this. Okay, so, oh my gosh. Okay, so now that we've ordered by descending, we want the first item of that. Okay, so a lot going on here, and here we have it down here. So we have the ID, we have the name of the plant, we have the state it's in, and then we have how much energy it generated and what fuel it used to generate that. Okay, so that's the biggest one in the U.S. in 2022. Okay, so now, and what can be helpful when you're writing these? I'm going to try one more time to set a breakpoint here. So what can be helpful with these is to use the debugger to inspect your intermediate results. So try this again. Okay. All right, so execute this, and if we inspect what this is now, generation units group by plant ID, if we inspect this, here we have this results view, so we can expand the results view, and then here's our keys. Okay, so these are the plant IDs, and we can open one of these keys, and then here are the values. Okay, so key 298 is the 4 generating units that are associated with the limestone fuel source. Yeah, which is located in Texas. All right, very good. So the debugger's your friend here, so you can figure out what your LINQ statement is doing at each kind of stage of the transformation here. As we add more clauses or methods, we're adding more transformations. Okay. All right. Should be good there. All right. So next one. On average, how much electricity in megawatt hours does a plant in California produce? So for that, we can grab the same logic here. So I'm gonna pick this up. Here, let's do this. So first, before we do the group by, we can do a where and trim down the data so that we just have ones that are located in California. And then we group by the power plant to get this, and now we have a list of power plants, and from our list of power plants we can compute an average, and we can say what we want to average, and that is the generation in megawatt hours. Okay. And so now can write that. Like so. Okay. Hopefully that works. Right. That's the key to LINQ. Is you don't know if it's really going to work until you kind of inspect this here. Okay, so the average power plant in California generated 442,026 megawatt hours. Okay. All right, what else we got? List the amount of electricity produced in each state ordered from the highest producing states to the lowest. Okay, so this is going to be similar to so in the previous one we aggregated on the plant level. We aggregated generation units to plants, and now we're going to aggregate from states. So to the state level. So to do that, we can do generation units dot group by, and we group by the state, and from these groupings we want to select out a new state Okay, and we're making a state object here. So we have these four properties we want to or these three properties. This is a dependent property, so that's good. We're good with that. We need to fill these three properties out on a state object. Okay, so our state code equals, I missed this here, group equals group dot key, and our electric generation in megawatt hours is the summing of all of the generation units that were in that state. So that is, we're summing the net generation in megawatt hours, okay? And now given our states, we can order by descending hopefully. Hopefully we can order by descending. Group by plant state, then we select, and then okay, it could just be my laptop struggling right now, so maybe we just put this here. Oh, why doesn't it like that? Oh, wait a second. What does that mean? State. Okay, so let's do this. Let's see if this works first. Set the breakpoint. It's too much. Generation units group by the state. Oh, that looks okay. Okay, it might be working. Okay, yeah, it works. It's just a the unfortunate reality that my laptop cannot handle this right now. Okay. And okay, and I forgot a property here. Fuel consumption, okay. All right, hopefully this works. All right, looks good. So on top we have Texas, 421 million megawatt hours, and then we have Florida, 228, Pennsylvania, 205, Illinois, 155, and so on. And so the lowest producing state is DC, which that makes a lot of sense. It's not even a state. So that looks good. It looks like that's working. Okay. And yeah, it's weird to write these. Your first time seeing this kind of syntax here. Okay. So now, what state burns the most coal for electric generation? So I'm going to borrow this, and this is most coal state, and before we group, right, we can trim such that we are only looking at generation units whose reported fuel name dot to upper dot contains coal. Okay, so we trimmed out all the generation units here, and then we're doing that same group by to aggregate onto the state level. Okay, so then let's figure that out. So council dot write line okay. Let's check that out. Oh, right. So this was, yeah. Whenever you see that means you're trying to print like a collection or a list, or in this case, an ordered enumerable. And because we're ordering by descending, the one with the most coal is going to be the first one. Okay. Okay, let's scroll down. Okay, it's still Texas. So that's, yeah, it's still Texas, and that makes sense. I mean, Texas generated the most energy, so I guess it stands that it's not unreasonable that they burn the most coal then. And so we can see that here, generation in megawatt hours. And then it just occurred to me that the fuel consumption is wrong. It's because I screwed this up here. Electric fuel consumption in MMBTUs. Okay. Okay, I'll try this again. Okay, yep. So this is how much energy that was stored in the coal that was burned. And this is how much electricity we produced from burning that coal. Okay, so there's some amount of efficiency to this process, and what we can ask is this question is, what state in the United States operated the most efficient power plants, and that is going to be the state where this fraction is lowest. Okay, so this fraction tells us the amount of fuel required to generate 1 unit of electricity, or more precisely, the amount of fuel measured in MMBTUs to generate 1 megawatt hour of electricity. So that's the last one here. And so I think we can, what state operated the most efficient power plants? And so I think we can borrow this. I think we can borrow this here. Except now we just want to order by this dependent property, generation efficiency. Most efficient state. Okay, but because the lower the value, the better. We want to order by instead of order by descending, and then we print that out. Okay, and again, this dependent property, generation efficiency, it's the same formula we see on our Word document. It's this divided by this. Okay, so now we run that. And scroll down. That doesn't look right. Okay, so let's figure out what's wrong there. Okay, better yet, let's just look at the solution. Okay, yeah, so I can't quite parse what the difference was between those two. But if we look, it was North Dakota here. So North Dakota evidently makes the most use out of their fuel that they consume. Okay. And so yeah, that's an idea of how LINQ works. It's really powerful, and you can really perform some sophisticated calculations here. But it does take a bit of learning and a bit of getting used to, especially the more complex things you do. So that's it for this exercise, and hopefully it comes in handy for homework 3, where you will analyze your own data set using these same tools here. Okay.